Okay, so here we are behind the Hammond B2, and we're going to start this up. There's a problem. It starts and runs, but there is a problem now with the start and run circuit. So let's see if you can figure out what it is. Here's the start. Click the run. Look at that. Organ starts and runs. But what's the problem? I'm going to flip this start switch. I don't know if you can hear it clicking, but that start motor will not engage when the run motor is engaged. Let's listen again. I'm going to hit the start motor. And it works. Now I hit the run switch. You hear that? The start motor just shuts right off. Let's stop it again. Now let's turn on the run switch. Okay, so now you can see we've got some resistance here, magnetic resistance. Now I'm going to hit the start switch with the run switch engaged. Nothing. So let's look at a schematic and see what that could be. Alright, so here's a drawing that I made, copied from the Hammond service manual, of the start and run sequence. So here's your power cord. You can see one side of the line comes down here, and it's permanently attached to the start motor, and it's also permanently attached to the run motor. So all we have to do is get power from this side of the line over to the start motor and to the run motor. Bingo, they're working. So the start switch has one contact right here, which the way it's pictured, it's normally open. Okay? So you see, if you engage the start switch, power gets to right here, and then what does it do? Looks like it can go one of two ways. It can either go through this resistor, which is 250 ohms at 10 watts, or it can go through this switch, which is currently closed. See the run switch? It's got two switches. One that's normally open, one that's normally closed. Right now the run switch is off. This one's open, which is not allowing any power to get to the run motor. This one's closed. And when you first push the start switch with the run switch turned off, and understand this contact, when you turn the run switch on, this closes, but this one opens. See, they're mechanically linked. So when I press the start switch, the current does not go through this resistor. The current goes through this switch directly to the start motor. So what you end up with is full voltage going right to the start. Now, once you turn on the run switch, closing this, you send power to the run switch. But you also open this, which diverts the current flow, which was originally going this way. It's now going straight through this resistor, which loads down, eats up some of the voltage and some of the power, reduces the power to the start motor. So when the run switch is on, you have a reduced voltage to the start motor. So our problem is, when the run switch is turned on, this contact's open, our start motor stops working. That means this resistor has to be open. And this resistor is located right back here, underneath this AC panel. Now, if the organ is plugged in, there's 110 volts here, and so you got to be very careful. You get zapped. Okay, so here is the 250 ohm resistor, 10 watt resistor, and this resistor here is not original. It's suspect. It's not even mounted properly, but we're going to find that that resistor is open. And if we measure across DC resistance, we got less than an ohm, but that's because the run switch is turned off. And if we remember, when the run switch is turned off, it closes this. So we're reading, when we put our meter on either side of the resistor, we're reading this switch, which is virtually nothing. So we have to turn the run switch on. That'll open this up and allow us to read. Obviously, we don't want the organ plugged in. Okay, so the run switch is on, and we have infinite resistance. So, all right, so we're going to get in here and clean up somebody else's mess. We have a 250 ohm 10 watt resistor here, which is going to go in place of this. But we also have some poor solder work here. Oops. Solder there. Bit me. Where's my other wire? Here it is. Okay, just a couple things to note here. Notice I've got maybe a 1/4 inch, 3/16 a 1/4 of an inch of insulation exposed. I don't want the insulation butted right up against the solder bus, because that's going to just melt the insulation when I heat it. Resistor, obviously. Last guy had it mounted up here. That's not a wise choice. This thing can get hot, and again, we don't want to melt anything. Get some solder. And we can complete our connection. Then we'll plug it in, and it should start properly. Okay, run the switch. Off. Plug it in. Contact. Start. There we go. Yeah. Let's shut that off. Let's go back into this scenario. Okay, run switch is on. Now we go to turn the start switch on. It should try to start. Yeah, man. Got a little ground hum here because I don't have the ground wire connected. Alright, so that solves that problem.